Hello, hello. Thanks for being here. We are in the ADI Books Deeper Dive. Today we're looking at chemistry. I am Krista Sampson, your moderator, and I am here with presenter and author Victor Sampson. And so he will be going over the tools, how to use those, and then jumping into chemistry. So I'll hand it over to him.
So let's talk about chemistry. So chemistry for high school, we've got two versions of our book. We've got one that's for NGSS and then one for that's aligned with for designed for Texas that's aligned with the TEKS. So in the NGSS book, you'll see these investigations here. I put a copy of the table of contents here. You'll notice that there are some that are similar for their Texas. Depends on how well the standards overlap, but what we try to do is write these investigations to tie in specifically to either the TEKS or the NGSS performance expectations, so you can really focus on those with this. What I thought to do today is go over an investigation called different melting points for cooking fats, and thinking about how the chemistry behind that. So I'm going to show you this one real quick of how this works and kind of walk you through all the tools that we provide in the book, and as well as our learning hub, which is kind of a extra tool that I'll get to here for a second. All right, so let's get started. So this investigation, different melting points of cooking fats, like every ADI investigation, starts off with introduction of a phenomenon. So we usually do those with videos. In chemistry, you could do your own demonstration and have students see things that are happening. The key part about any phenomenon is they can observe it and then try to explain why it's going. So you don't want to tell them how it works at this point, but you want them to start thinking about why that might be, why or how it happens. So when they see that phenomenon, they're going to record some things that they notice on their own. Then they can share them out as a class. Then in this case, what they always will bring up is they sort of melt the fats in the video melted at different rates. So that leads right into our question of why do these different cooking fats that we use have different melting points? So not that it's just they do, or that's a property of them, but why that's happening. From there, we have each student then try to build a model based on their experiences of, well, why would this be different? Like, what would be causing that? What do you think is going on at the at the atomic level that might help explain why this is happening? They draw those out, share those in their groups. As they're sharing with the other people in their groups that are going to have a bunch of other questions, these are things they're uncertain about. And you can use those uncertainties then to generate more questions that they want to have answered, which really increase the vested interest in this kind of investigation. Now, to support you with that, what we also do when you purchase one of these books, it comes with a book code that you can go to our ADI Learning Hub, which is adilearninghub.com, and you can create a teacher account for free. All you do is type your name in and your email address, so you have a free teacher account. Then you can enter the book code. And then once you enter the book code, it pulls all of the investigations that are in that book that you purchased into your library. Once you have them in your library, you can see the standards for them. You can download all the handouts, so you don't have to photocopy them out of the book, and you can also download them and put them and make them in color if you want to. And most importantly, it has a presentation mode. When you click on the presentation mode, it acts like a slide deck that you can use to guide students through investigation. So this picture here is from the first activity in this investigation of introducing the phenomenon. And what we did then is embedded all of the videos in there. So you can see this is that. If you click on the little icon in the upper right, it actually blows up and goes full screen and makes the text a lot larger. So it's a really easy way for kids to be able to follow along and see what's going on. Let me show you this video here real quick as an example of a phenomenon for this investigation. This one's a little bit of a longer video because it needs a few minutes to actually let things start to melt. But as you're watching this, they'll be taking notes and that things. And as you move forward, you can kind of see how you end up with more different rates on that. Okay. That gets them to start thinking about what they noticed that happened and why that happened. From there, then you can ask students to go ahead and share things, write down things they notice in their handout. We add these pieces so they look just like their handouts so kids don't get lost. You can say that's the bubble where you write down your things, then they can share out and move on. So it's all built in there for you to make it easy and cut down on your prep time because none of us have enough time anymore. From there, once they have all of these new questions, a lot of them are going to be related to the core ideas and cross-cutting concepts that are found in the NGSS, or kind of the concepts or recurring themes that are found in the TEKS. So for example, in this one, we first introduce structure and properties of cooking fats. So what's inside, what makes up these cooking fats, right? So what's different with these, how these molecules, what percentage of these are composed of these different molecules, and what do these molecules look like? What I will often do when I'm first teaching one of these, especially at the beginning of the year, and I'm not 100% sure about all my students' reading comprehension skills at that point, what I usually do is just read this out loud, have them follow along, and then in groups talk over and try to identify things that were useful for answering the guiding question of why we've got different melting points for different kinds of fats. They do that in a group. You have them share out. After every group's done, you can have those on the board and then can instruct kids to write down anything that they missed. So it's a great way to practice actually looking for information that's meaningful and not just looking for answers to questions. Right. So thinking about being kind of more evaluative of what you're reading and trying to decide if this is really helpful or is this just extra information that's not really pulling in. From there, we start talking about forces within and between molecules. I know when I first learned chemistry, there was not I don't think there was enough focus on this. Such an important idea of talking about how these forces hold atoms together within molecules, but more importantly, how forces across molecules interact and what kinds of there and how they're different strengths and those kinds of things. So we introduce those ideas in there, talk over that, really helpful for them. Same thing, identify useful ideas, and then finally end up with the cross-cutting concept of patterns, of how can you use patterns to help answer this bigger question of why a difference. So we kind of introduce that idea. At the same time, we also talk about how you can measure melting point, right? So by looking at patterns in those is a great way to do that. So from there, what we do then is, sorry, before we go on, once again, in the Learning Hub, we have all of this text in there that matches what's on the handouts, kind of chunked up so it's easy for you to read. So you can read this up there, but most importantly, the images are in color. And if you click on any of these images, they blow up to full screen. So we all know when we copy things, the copies don't always come out really clear, right? You'll end up with darker things. Kids can't see things, especially if it's a copy of a copy. So if you use this, then you can see a really clear image and you can take a second and point out anything for them that you need to, or just have that up there so they can look at it as well while they're reading those texts. And once again, you have everything like the idea bubbles on the handouts up there so you can point that out as you're moving along. I can't tell you how useful this is in terms of kind of facilitating an investigation without having to make my own slide deck around it. Super handy. After you finish the idea stage, you move on to the plan stage. You want to start the plan stage with a tool talk. So talking about any materials or techniques that they can use. I like to have the physical materials out on a table so I can kind of hold them up and say, what might we use this for? In this case, they need materials so they can actually calculate the melting points of these different fats. We also include images in the Learning Hub, so if you don't want to get those out for this point, you can put those up and talk through that as well. Once they see those materials, they can go ahead and make up a plan. We use these graphic organizers to help them do that. It's really trying to get them to think about not necessarily just following a procedure, but being mindful of why they're getting the information. So what's your question? What observations or measurements that you need to collect? How are you going to collect those? Show me a picture of how you're going to set up your equipment. I always like to have them add safety things, like what are you going to do to be safe in your picture, and then what are you going to do to analyze your observations, your measurements once you have them. What's nice about this is as they're working in their groups and they think they got a plan, they call you over and then you can sign off on it. There's a little spot for there as a stopping point. So if it looks good, great, go get them. If they need a little nudge in another direction, you can give them that nudge with advice and have them revise things before they get going. But at the end of this, they have a really good plan that they came up with. And most importantly, they know why they're doing it, not just that they're supposed to do something. So from there, they can go ahead and start carrying out their investigation. In this case, they're going to find the melting points of a different cooking fat. So they'll be using this equipment to figure those out. Once they have that, then they can relate that information to the different structural properties of these different fats and find a pattern in there that'll help them explain why. As they're working on this in their handouts, they'll have a spot to write down observations or measurements they take. Once they have collected that data, then they can start transforming it into evidence through analysis, right? So they can look at differences between different fats, relationships over time, those kinds of analyses in that point. And at the end of this, they should have an answer to the guiding question of the investigation. So once each group has an answer, it's their tentative answer, we want them to share that out. So then they share that claim that they're making along with their evidence for it and a justification of their evidence. We add that to these whiteboards that makes it easy to present information. They almost are the size of posters. So kids with dry erase markers can write down their ideas and then they can share with each other and give each other feedback. Lots of ways to do that. You can have them do a gallery walk. You can have them do a modified gallery walk where you have somebody stay behind and talk through things. You can give them sticky notes to go add comments or critiques to these different things. On the handouts that we give them as well, there's a spot for them to record good ideas. So if they're at somebody else's board and looking at their argument, they see a great way of displaying evidence, they can write a note to themselves and bring that back to their group. If they're presenting their arguments, they can write down the advice they're getting from other teams, and then they can reconvene, go over all the things they learned from other folks, and then revise their argument and make it better. So it's the strongest one that they can at this point. To help them out, we also add extra supports in the Learning Hub that you can show up on the screen. This is just another representation of what you can put on a whiteboard to represent your argument. So they're getting stuck. Hey, what do we mean by evidence? What do I put here? You can add this as well. Put this on the screen and kind of give them a just-in-time support for what they're doing. After they've revised their argument, everybody should be on pretty much the same page and have this same shared answer for why we have different melting points for different kinds of fats. So at that point, you want to bring everybody together and have a reflective discussion about first the core ideas and then the practices of science that they engaged in. So in terms of core ideas, what we recommend doing is showing an image. This image was one found in the ideas section of their handouts that they were working through before, but this time it's not labeled, it's just given an A and a B. So what I always do is I put this up on the screen and then I ask them, what do we know about, what can we use about what we know about intermolecular and intermolecular forces to explain what's happening in this images? Like, why would they be different? Where are they coming from? What's holding this together? You have each of these groups talk over what's going on there. They share out their ideas. You can have other groups add on, disagree, change ideas. Once you kind of got a consensus there, then you as a teacher also, if you need to, correct any misconceptions, add anything to that. But it becomes a really great way to kind of showcase kids' thinking at that point. Then from there, what you want to do is engage in a discussion about the practices. At the high school level, we really want them to start thinking about how they can generate the highest quality evidence that they can. that often kids are not really sure why some ideas are accepted or not in science and what makes evidence of high quality. So what we're really trying to focus on, since the importance of evidence is what counts. So we try to frame the discussion around how can you engage in the practices to increase your confidence in the quality of the evidence you're making, right? Because how do you know if it's good or not? That's one of the big questions of science. So what are the checks and balances, so to speak, that you can put in there? What are things that you did during your investigation that made you less confident, right? So maybe we change those things next time. And then finally, what should we do next time we do an investigation? What rules should we put in place, or what things should we keep in mind? Great way to help kids learn from their mistakes, because mistakes are opportunities to learn. We have a handout for the reflect stage. So after you have that discussion, I always recommend giving the students about 5 minutes to write themselves a note to their future selves. What is it that you want to remember about the content that we were talking about? What do you want to remember about doing science for next time? It's a really great metacognitive activity that they can really think, well, I used to think this, but now I think this, and they can keep a record of that. And by writing about it, it helps it solidify in their minds. Adding on to opportunities to write about what they've learned, we now have each individual student write a report to share what they figured out. The reports are not designed to be 15, 20-page things. It's usually one piece of paper, 2 sides. It consists of an introduction, a method, and an argument. So the introduction is just what were you trying to figure out and why. Your method is how'd you do it? Like, what did you decide to do to answer that question? And then your argument is basically taking your group's ideas and turning them into your own. What did we figure out? What's my evidence for that? And why is that evidence important? So they write those out. We in the book include these sentence starters just because it's the first time you're learning to write something like this. This might be overwhelming, especially for students who are not used to doing a lot of writing in science. So that kind of brings the entry point down to make it a little easier to get started. I only use these the first 1 or 2 times, and then they're either typing it or writing it out just on a blank piece of paper because we want to take those scaffolds away as they get better. Once every student has their draft report written, what we ask them to do is peer review them. How I recommend doing this is putting your students in your class into groups of 3. So for example, if you have 30 students in your class, you'd have 10 groups of 3. They can be the same groups that were working together on the investigation or different groups, doesn't matter. But for your peer review groups, you want groups of 3. So once they're in their groups, you give each group a one report written by somebody outside of their group and 1 peer review guide. Then as a team, they elect 1 person to record what their response is going to be. Then they read the report, fill out the peer review guide. Anything that they say no or somewhat to, that means it needs to be fixed. They add feedback to that. Give them 15 minutes. At the end of 15 minutes, you collect those peer-reviewed reports, give each group a new report and a new peer review guide, have them change recorders, give them another 15 minutes to review. Then finally give them 1 more report and 1 more peer review guide to review, change the recorders, 15 minutes. So what you end up doing at 45 minutes is every group has reviewed 3 reports. Everyone in that group has been the recorder, and then everybody that wrote a report has been reviewed by a group of 3. And so not only do you get good feedback from your peers, but you also have a chance to discuss what counts. So the debates that kids have about what counts as good evidence, is the claim consistent, is that right, all helps them learn the content and how to write better. Really powerful way to help kids learn during this model. After that, it goes back to the original author. They can look over their feedback, think about what they talked about during the reviewing of other works, rewrite their investigations. You can give them a handout again or have them type it, totally up to you. And then what I have them do is turn in their first draft, their final draft, and the peer review guide that was filled out by a group. And then I use that, or you can use that as a final rubric to score it. So there's a spot on there where you use the exact same criteria, the same questions, you get that a teacher score, no surprises, everybody knows exactly what's on the rubric, and you have a nice summative assessment of student learning for the investigation. So Yeah, that's an ADI investigation, or this one specifically. Now, if you're kind of thinking to yourself, that was a lot, how am I going to ever remember that? Don't forget, in the books, we have detailed lesson plans for each of these investigations. And we really try to make these investigation or these lesson plans detailed without being overwhelming. And so how we did that is we always start out with an overview, like what are the kids actually trying to figure out and what is it that they are going to figure out. Then we include this graphic that talks through kind of the stages of how do you divide those over multiple days. We assume you've got a 50-minute period at the high school level. So how do you break those? You can do a couple stages in one day, another one. So that kind of talks you through that. We list the standards, not only just the science ones that you're addressing, but also language development and English language arts standards, reading, writing, speaking, and listening, huge part of this model. So it allows you to kind of think about all the things you're helping kids learn how to do. We also include information about things to know during the lesson. So what are the core ideas at the heart of it? These are the things you'll find in the idea stage and what you want to discuss during the reflective discussion, along with the cross-cutting concepts and an overview of the practices. We also include tons of information about the materials you need. So we give you a list for what you need for an entire class and for each group. We outline kind of a basic procedure that students can follow when they're collecting data. Doesn't mean that you give this to them, but this is for you so you can start thinking about how they might do that and what hints you can give them. We overview safety precautions, waste disposal, all the things that you need for teaching chemistry. And then finally, we include a section that tells you what to do during each activity within a stage. So you've got, for an ADI investigation, you had 7 stages, but you have different activities within each stage. So that's how we kind of broke this up. So this image here shows you the first 2 activities within the task stage. And it always tells you about how long it's, how to group folks, how long it should take, what you need, what you can do, what you should give out, what you should show. It's not a script to follow, but it's kind of documents how I would do it when I'm first teaching this. So it gives you something to start with. Feel free to modify it for your context. And then finally, we always have teaching tips. Those usually are around management kind of things to keep in mind. And then a box that's labeled attending to equity, and that's thinking about ways that you can support learners who need extra support. That might be someone that's a bit of struggling with reading, maybe are learning or new to English. Maybe they're real quiet in class and feel like they don't feel comfortable sharing their ideas. These are all ideas to kind of bring out and support all of these students that are in your class. So we add those in there for you to use. All right, that's the overview of chemistry, or the deeper dive to that. Are there any questions that I can answer right now?
Yeah, we have a couple. The first one comes from Alyssa, and she wants to know, how can I support my students in giving meaningful peer feedback during that stage of ADI?
So I assume the peer review part that we're talking about, right? So when we're talking about doing the peer review, a lot of things that we already built in there was based on that question, like how do you get kids to give each other good feedback? When we first started doing this, we just said switch papers and have them and review each other work. That was a disaster. Don't do that at all. So that's why they do it in groups. Part of that, having a peer review guide, those questions on there are designed to be general enough that they don't just go hunting and hunting for certain words or for if it's there or not. It's designed to think about, is it of high quality or not? So when you ask a question, is like there enough evidence? Students will, in that group, will say yes, no, yes, and then they have a better discussion. And once they have that discussion, it's easier for them to actually give feedback about what that would look like. So most of the time what I do is I prompt them along of saying, hey, that thing you were just talking about, tell them what would make it better or stronger and those kinds of things. And the first time they do this, it won't be great. But once they realize how valuable it is getting good feedback, they'll be begging for people to do a good job. And then collectively, they will all try to help each other out. It works really well.
Excellent. And last question from Isabella. I have students who just want to be right. How do you help them value the process of figuring things out?
Oh, sure. So part, it's a very good question. So part of this is kind of our school system, right? Where kids get used to, if they get the right answer and they get it quickly, they get the points that they need, and they can get on to other stuff they're doing. Kids are super busy anymore. So there's kind of this always this fight, just tell me what I need to know so I can get done. Part of what you this allows you to do is emphasize the process more. And the first time they go through, you will get pushback of, well, wait, you didn't give me the answer here, or how do I know that? You've just got to take the time as a teacher to explain. You're not going to be penalized for being wrong. Part of what science is figuring out the unknown. What do you do when you're not sure about the answer? Well, we rely on evidence. Well, okay, how do we know our evidence is good? Well, we put all these checks and balances in. So we're trying to help you have an experience of thinking and acting within a community of science. And once you start doing this a little bit more, kids are like, oh, I get this. I'm good. Part of it is just it looks different than a typical class period. So there's always going to be a little bit of tension there at first.
Excellent. Looks like that is it for questions. So I will let everyone know about the upcoming webinars tomorrow.
All right, we are finishing our deep dives tomorrow. So we're going to do some physics at 4 o'clock to 4:30, and then we're going to do integrated physics and chemistry, which is a Texas specific course. But we thought we'd talk over that one and go into a deeper dive into that book as well, because that's one that doesn't correspond to the NGSS, kind of like our space science one was. Anyway, come join us tomorrow for these two of our last deep dives.
All right. Thanks so much for being here and have a great evening.